This is Thursday, the last week in May 2013. What you're looking at here is a Takagi T-KJR that was purchased back in October of 2005. So you can do the math. It's somewhere in excess of 7 years, going on 8 years of service, and never had a service of any kind. But got to a point where it was just taking too long to heat water, and then it would get to a point where it wouldn't fire, and that became very intermittent. And so I talked to the people at Takagi, and they said, well, you need to do a service on it and flush the boiler and service the furnace or the combustion chamber, and while you're at it, polish the temperature sensor next to the igniter. All those things were done. I back flushed it for 45 minutes to an hour with CLR, 1 quart to 3 quarts of water, or 2 quarts of water, and pumped it through there for 45 minutes to an hour, and got some junk out of there, but it was surprisingly clean, having not been serviced for that length of time. Also sprayed down the combustion chamber module with 409 as dictated by Takagi. I let it set for 15-20 minutes, and then came back and rinsed it off really good, and then blew it dry with some compressed air. I have an air compressor which helps, and dried it off completely. Put new washers, not new washers, but new seals all the way around on each of the items, and reassembled them, and still had a basic problem with the thing being intermittent. This went on, off and on, back and forth with Takagi with suggestions for, oh gosh, 3-4 weeks. Finally, I saw a small thread in an internet discourse about a possibility that the overheat fuse, and I'm going to point to it here, it's this wire here, kind of wire-like material. It's got a blue woven, I'm going to point to it here, that comes off the front, and there's another piece that comes off the, I'll go way back in here and touch it with my finger, off the back, and that's the same thing there looped around, and it attaches all the way around the boiler and basically sends information to the computer down here, the circuit board, that tells it that there's not enough water flow through the heater to match the heat that's being given, and being a flow issue, then you get an overheat issue with the boiler, and that's designed so that that fuse will either become semi-workable, which creates much havoc because it gives all kinds of false signals, or it just is completely no continuity. There's a break in the line, and of course that shuts down the gas valve. So then when you try to fire this thing up by turning the hot water on, what you get is you want to do this in kind of the semi-dark, if it's where if you can, and you look through the little port window here. I'm going to point to it right there, and look kind of to your right as you look through the window. You'll see the igniter functioning. It'll cycle through, and you'll see it try to ignite, and you'll hear the little buzzing of the igniter in there. But then you should follow by a kind of a clunk, and if you don't hear the clunk, that means your gas valve isn't opening. Well, that's what it got to, a point where the gas valve wouldn't open at all. And so, and it didn't matter what you did, nothing. I repolished the sensor for the high limit gas sensor, and nothing happened. Oh, see, so I got to thinking, okay. I also put, when I was going through this, I bought one of these remotes. The beauty of the remote is that it gives you a specific area. We look down here, there's a little red light in here. You can't see it because of all the wires, but it's back in there somewhere, and it blinks and gives you a 3 blink on consistently, which means it's one of 5 possibilities. But when you get the remote, it gives you the specific air and it reads out. And there's also a little burn light up here, like down on the circuit board, that comes on when the gas is ignited. And then over here you have an information. When you punch that once, it gives you the inflow temperature of the water coming into the unit, cold. You hit it again, it gives you the temperature of the water going out, and then you hit it one more time, and it gives you the flow, the water flow from the source that you've turned on for hot water. All those things are really helpful in diagnostics. And basically, you got to look at the charts, and Air 11 has nothing to do with the flame sensor, because flame sensor is Air 12. And so I thought, well, if we've eliminated that, we don't have to worry about polishing that sucker anymore. So I got to thinking, what would shut down the gas valve? Well, there has to be some sort of a limiting device to make this system secure for overheating. And so after I read that thread about this particular fuse here, this thing right here that wraps all the way around, goes around to the back and comes out over here, and then a wire comes out the front and a wire comes out the front at the back, and then it hooks up to this harness right here. These two things I'm showing you right here hook together, and that feeds it back up to this sensor up here, which is the boiler, also high limit sensor, and down to the computer down here. So what you have is, you can check it for continuity by just taking the wire coming off the harness, which is here, and putting one probe in one and the other probe in the other, or if you can't reach it because the hole's so small, just put a couple of pins or needles in there on either side, and then check it for continuity. And when I checked for continuity, it was open there. It was not a completed line, in other words. I checked this up here by putting it on here and here to check for continuity, and this particular pop-out fuse was fine. So I eliminated that as a cause, eliminated the flame sensor as a cause. So there wasn't a whole lot more to look at other than maybe the gas valve. And you talk to people at Takagi and they say they've been making these things since 1952, but the company's been in business since then. So if after all those years they can't make a decent gas valve, and those don't go bad that often, it would make sense that you'd spend more time checking this crazy fuse here. So just to show you what it looks like, overnighted the part, and the part is this. I gotta see if I can focus it here for you. It's ASU 390, and it says on here high heat fuse, basically, and it makes sense, perfectly sense, when you start to think about what it does, why it went wrong. So the suggestion here is that if you're having problems, the very first thing you do is order one of these. Now, these things used to be, these remotes used to be like 124 or something like that. Now they've marked them down to something like 84 if you look on the different websites for parts, and get that for your starting. I mean, it's going to cost you that much to have some guy come to your house and look at it anyway, so why not get it? And you can also change the temperature when you want a little bit hotter water, and then you can move it back whenever you want. That's a nice thing about the remote. You can also put it in the house, but it is a wired remote, so you'll have to run some wire, basically number 18 bell wire, that sort of thing. It's non-polarity, which means it doesn't matter which two wires you hook up, as long as you hook them up where they tell you to hook them up, and be careful that you make sure that you're hooking it up in the right place, and they hook up right here. Okay? The other thing you'll notice on my Takagi is I have a shutoff valve for the cold up here. We follow the piping down, it comes across, and the cold goes in here, and the hot water comes out, cold comes in here, goes out here, comes up, and I put a hot water spigot on so I can have hot water in the garage anytime I want it. We go further up and we have a shutoff here on the hot water. That's for my back flushing. And then down here Here's an extra tap with a shutoff and a cap in case this gets accidentally opened. You know, that's to drain the unit or back flush the unit with the hot water and the cold water shut off. I just back flush it through here and open my hot water tap, and this serves two purposes. Okay, that's how I plumbed it. Okay, and this is my install. It's got I believe that is 4-inch double wall stainless steel as per code on this unit, and it has a drain because of condensation on these units because they're power exhausted. And you want to make sure that your seals are all nice and tight, and that you don't have any air leaks. So all these are banded and compressed. Okay, all the way up to the chimney. This unit cost $520 new, and it cost almost as much for the stainless steel pipe because it goes up through my garage roof and is 3 feet above the level of the garage roof. So there's a fair amount of stainless steel chimney there. So now you have all the particulars on this. What I'm going to do is go to work on this thing and tear it apart and see what I can do to get to the problem. You have a very nice set of instructions that comes from the people at Takagi to do anything on this unit. It's already had its maintenance and cleaning, so basically I'm going to tear it down just to get the boiler out so that I can take that fuse wrap off and put a new fuse on and then reassemble it. So I'll talk about that and give you some pictures or maybe even some motion pictures of what I'm doing as I do it and as I go. It's kind of going to be a new experience for all of us. I'll talk at you in a bit. Okay, so in the disassemble to get to the boiler fuse, the first instructions are to turn the water off to the unit. So basically there's a cold water turn off there. You come over to the other side, here's a hot water turn off here on mine the way I plumbed it. And then basically what I did was open the drain here on the bottom, which comes off the cold water side but also attaches to the hot water side indirectly, of course, and opened it up. And there's a little air release petcock here on the side that you just can unwind if there's any kind of a airlock for draining, which there isn't, and it's basically all drained now. So also there's the switch turn off for the unit, and here's the gas turn off on the gas line. Comes around and goes to this standpipe here, which comes down from the overhead crawl space, goes to the furnace on a T. And also, as you can see, the smaller pipe, which is 1/2 inch, goes to the furnace there on that T, and then the other one is 3/4 inch, goes to the Takagi, which is their recommended pipe size. Doesn't become a real issue until you start cranking the BTUs and the gas flow for the furnace. So after you get, say, over 400 degrees, you're going to want the larger pipe because it won't be able to fire it consistently and it'll kick out on you. So from here we'll go to the next step. Okay, your instructions first tell you to, of course, turn off the power, turn off the gas, turn off the water. Then the second set of instructions say, which is number 3, tells you to remove the fan motor clip from the printed circuit board. And you really don't see that until you do the second step, which is remove the screw holding the printed circuit board, and it attaches. I'm going to point to it right here, and it uses a little bracket coming off the top of the printed circuit board, which is kind of upside down now, but I can turn it up so you can see. There's the bracket right there. This is the top. Turn it right up so you can see it. Then you have to pull these wires that you see right there out of that little alcove that I'm looking at right there in the middle, so that you can get this, they don't tell you that, so you can get this printed circuit board to kind of hang, which is what they're telling you to. Just don't disconnect everything, just let this printed circuit board in the plastic case after you've removed the screw hang down like that. Now, in so doing, I noticed a fuse holder back here for the whole system. And even though the unit's turned off, I just opened this up, took the fuse out. It's 250 volt 3 amp fuse, and I took it out and just left that open, and I'm going to get a new one. Just as a precaution, while you're there, why not replace it, even if it's good? Learned that lesson the hard way, and I won't talk about it this time, but it looked good and it wasn't good, basically. So we know what the problem is, but we're going to do that just as a backup, and that'll make everybody feel, myself included, better. But anyways, now you're looking at what I'm looking at. So we'll go to the next stage after this, and I'll be back. So the next step was to move the screw, which is attached right here. I'll point to it right underneath this wire. There's a release right there. And your bracket, I'll show you here, there's a screw comes right out there that attaches to that spot. And then you can drop down the ground fault protector, which is this module here, and you can kind of let it hang. It doesn't say to disconnect anything, just kind of let it hang. Now, I'm still looking for the clip that you disconnect for the fan, because I have a feeling that that is going to have to be disconnected when you move some of this stuff out. But we'll worry about that after I get some of the other maintenance done, because I have a feeling it's going to be pertinent when you try to release most of the unit to get the boiler out. Okay, so the next set of instructions tells you to take the two wires off of the high limit fuse here, or sensor. It's on the boiler. Okay, you can see it's kind of mounted on this boiler pipe. This one checked for continuity, by the way, and it's fine. But you might want to know that they go on kind of like this, and then the other one kind of goes on this. But if you look, I don't know if I can get in close enough, but in the middle of this slide on here, there's a little tiny thing that's spring mounted. I'm pushing my thumbnail on it, and it releases because it catches on these two little, take it off so you can see. I have to pull on this, push on this little tiny tab here. You can't hardly see it. It's between these two runners here, if you will, that slide on, and you have to push on that to get it to come off. At least that's the easiest way to do it. I didn't want to break it. And this one, of course, is mounted with the tab that you have to compress on the back side. So I had to pull this tab forward a little so I get my finger around it, and you can actually put your finger on it like that toward the back, and that's enough to push on that thing to release it. So that dismounts the wires, or disconnects the wires from your heat sensor kick out here, safety device. And then it also tells you to take your wires off of your flame sensor, which is this side, and then your igniter, which is this side, and they are both pull off, and they have nothing but a pressure fit. So I'm going to pull this one off to show you. It's round, where the other one, of course, is kind of like the one I just showed you. It has a tab, but it doesn't seem to affect its removal like the one I just showed you. So I'm going to pull this one off. You want to grab the wire at the collar and pull slowly and carefully, and it comes right off. And let these wires just kind of hang. If you're afraid of where all these wires go and you can't remember, just make a diagram. That's the beautiful thing about also videoing this. I'll know where they go, and since I've taken it apart and put it back together again from the standpoint of service, I really know where they go, so it's not a big issue. So let me see what the next part is. Here's the instructions I'm using, actually. So we have taken the flame sensor off, and wire off, and the igniter wire off.
blue connection to the overheat cutoff fuse, and black and white wire left. Three from behind the power, from behind the printed circuit board, purple, black, white, and purple, black, and white and black. So it tells you what wires you need to disconnect now, so that you can get ready to kind of pull this thing apart. So that's what I'm going to do next. So then the units tell you, the instructions rather, tell you to make some specific disconnects on your cable, on your cabling, so that you can move things around when you finally get into disassembling this system. And so it tells you to disconnect this one here, and you notice I have marked these with my own colors of fingernail polish, so I know exactly what goes. So this one goes to this one. There have two. It's kind of that color, and then this is a brighter red, and it connects to this one down here. So it goes up here to that. See, and then this one goes to that. This one down here goes up here to this one. And if we look down here, this one has one dot instead of two, and it connects with this one here, purple to purple, purple to purple, and then this one back here connects with this one over here. So everything's marked, and this of course is the fuse wire here. So now all the disconnections are made from the standpoint of the wires or cabling. So next we're going to go to dismantle the firebox or furnace, if you will, and that sort of thing, so we can remove the boiler. So the next set of instructions tells you to remove the four gas manifold screws, and this is the gas manifold down here. Of course, it's been released now with the gas valve, okay, and you're seeing it upside down, and these are the ports that bring the gas into the burner. But you take these four screws out, and when you look at your instructions, you don't take the fifth one out. That still holds the manifold to the gas valve, and that kind of protects your O-rings and that sort of thing. But then the second thing you do after the four screws is there's a screw that mounts back here and screws into that from right here, and that holds the gas valve down, the manifold here rather, down the gas valve rather, down over this O-ring nipple, and this is the receiver for the screw that goes in here and holds it in place. So when you take the screw out, as it tells you, you have to lift up on this assembly so that this part here, this neck, pulls off of this post here. So you lift up gently like that, and then evert the thing backwards like this and let it hang gently. Now remember, you got a lot of wires connected here, and you don't want to do anything roughshod. You want to do it kind of nice and easy, just like they say, so we don't make any unnecessary repairs or have any unnecessary repairs of broken wires. You'll get a slight odor of gas. Preferably you were smart enough to do what they told you and turn the gas off prior to this point. If not, you'll have a lot of gas odor. But turn the gas, make sure the gas off. But when you open that up, of course, that pipe will be open to the air, and you will smell the indicator in the gas that still remains in that line as it vacates. Not very much to worry about. I'm in an open garage, so not a big deal. We'll continue here in a moment. Also, when you remove this this gas valve assembly, or whatever you want to call it, you want to make sure when you lift up and then hang this down over like it tells you to, there is a screen inside of here. You want to make sure that it is there, and if you look, you can see it. Probably not very good focus, but there's a screen right there. And then you want to make sure that this O-ring doesn't come off, because that's a very important seal, obviously, for gas leak, to prevent gas leak. So when you assemble it, you want to make sure you have that pretty vertical when you put it down on that post, that you don't crimp that O-ring and you get it sealed. Of course, you're going to do a gas test leak at the end anyway, so but that's just something to think about. Now the next thing we're going to do is we're going to take off the 5 screws here. 1, 2, 3, 4, and 5. You'll be taking this hanger off, which goes to the orange wire. Okay, you can just roll that around the orange wire like that and leave it on there, and that'll remind you to put it back. It goes on the top. And then the green wire is your ground. This is a very important wire, and when you reattach this, it goes below the red wire, which is just a hanger. This thing here goes to your sensor. To your sensor, flame sensor. And the one on the other side, of course, goes to the igniter. But anyways, this ground wire here, you want to make sure that you screw this down nice and snug, because that grounds the unit. And if this isn't grounded properly, you may have other problems and think that you've got something else when it's very simple. So just make sure you have a good, tight, snug fit there. Just some thoughts, okay? So I'm going to let you see how this furnace module pulls out. There's a lip here that wraps over the boiler, okay? And this thing just slides out like this. This thing actually fits underneath this lip right here that I'm pointing to. So this whole thing slides out like this, and it looks kind of like that, okay? Sorry for the movement, but I'm trying to do this with one hand without messing anything. You know what's really interesting about this unit is it comes apart quite interestingly from the standpoint of the plumbing. These connections here over these, I don't know if you can see it, here's a pipe with an O-ring, just like your pipe or post with an O-ring here. This is for gas, this is obviously for water, this is incoming cold water, and this is outgoing hot water. And they have these clips, I'll show you them, and that's what holds the thing in position. There's 3 for this system here, which is composed of this whole mechanism here, and then this is part of it. This fits back on top of here, okay, like that, and then that piece that I just showed you fits in there and connects. But anyways, it all comes apart quite nicely. I would say it's very important to take pictures of everything that you're doing here so that you can keep track of how it all goes back together. It's not really all that difficult if you're technically oriented. If not, and you don't understand what you're doing, I would say, hey, get a repairman, don't mess with it, because there's a lot of potential for things to go wrong here, but it's all about being systematic, okay? Here's inside your firebox or furnace, if you will. Here's your power fan below, okay? It's controlled by your printed circuit board, which is hanging, of course, right now. And there's a distribution vent here. It's different angles to make sure that you get a good circulation of air through the burner. And then, of course, you have another sensor under here for heat and that sort of thing, I'm sure. Tell you also to inspect the gasket, and the gasket is all intact except for a little piece here, so I'm not going to replace it because that'll match up when I put it back in. So we're now getting ready to get to the point where we actually pull the boiler out. Just taking a picture of all the wires and all the connections in case I needed to reassemble this mess. What you basically have to do is make all your disconnections and get these wires all out of the way, so this whole thing from the fan all the way to the top can slide out. This drops down, comes out of the chimney, And the last thing you have to do is pull this back collar up and then disconnect that so that you can free it. Okay, so now you're looking at what it looks like when you've got it taken apart so that you can work on this crazy thing. There's not much left. You got the wire coming off your transformer there, and you've got your printed circuit board, your ground fault, and your gas valve all kind of hanging. I got them supported with an extra piece of wire, as you can see, hanging from that faucet there, so we don't pull any other wires loose in the process. But to get this thing out was a bear, because this back thing here has a 1-inch sleeve on it. You take the clip off, it rises up, or it's supposed to. But the piece of plumbing plumbing coming from the boiler comes down, and it was angled backwards kind of toward the case over here, and it was putting pressure on that ring so that you couldn't pull it up. So you had to get a pair of channel locks or pliers in there with enough clearance, which wasn't much, and move it back and forth till it would kind of slowly raise and pry off. And then I saw there was also some corrosion on here, probably a little bit of calcium. But it was more the angle of the pipe that was put in there in the first place when it was manufactured. Just a slight problem. See if we can't adjust it on the way back in. But interesting, always interesting. So to give you a look at what it looks like, okay? Here's the unit. I'm going to get down on my knees so you can see it. This is from the front, and of course it's upside down. So the boiler is now on the bottom as opposed to where it would normally be on the top. And if I turn it over, well, I'll show you on the back of the boiler first. This whole mesh that you see here, that hull has to be taken off and a new one put on, and then the whole thing reassembled. And as you can see, all this stuff here, that's what has to come off, and then you put the new one on. And that's called your high heat fuse. And the unit will work intermittently when that is not totally gone, or still works a little bit. So on a continuity test it might give you partial, and that's when it gives you some really flaky problems where you think it's your sensor. So another surprise that I got was I took the fan off. I got to thinking, well, while I have this unit out, why don't I completely service it? So I'd already backflushed the boiler previously, about 3 weeks back, and I'd already cleaned out the firebox. But when you look at the unit from the top down, the chimney down, you can see all the dirt and stuff that's connected between the fins on the heating elements, the copper pipes that go through the boiler, and where the flame goes through. So a good pressure blow, and I talked to the guys at Takagi. They said maybe a good spray down with some diluted CLR, and let it sit for a bit, and then rinse it off real good. But you want to make sure that you protect your fan motor. Well, the easiest thing to do is take the 3 screws off that attaches it and separate the fan. And then I thought, well, while we have the fan off, we better take a look at, see if the fan's dirty. Well, it's not very dirty, but what happened is when I took the fan off, out drops a beetle and some other bugs. You know, there they are. I'll bring them down. There's a big old beetle. You know, there he is right there, and a bee or some other stuff. So, you know, just some more junk that's not in a place where it wants to be. And how they got in there, I'll never know, because that is got some screen to protect the intake on the air on the cover. So, but you know, bugs will be bugs. But once I get this all CLR'd and blown out and cleaned, I'll reattach the fan after taking the cover off and checking on that to see how dirty it is. Maybe clean that too, blow it off at least, and get it all reassembled. And then put that new fuse and wrap it around. When I get that done, I'll show you what it looks like just before I insert it. Well, it's several hours later, and just turn it around now. and got it all back reassembled. I might mention that you put that back in, you really have to have this part of the chimney here pulled over one way or the other. Since I have a pipe there, I can't pull it that way, so I had to pull it this way, and so that this can be bent and slid up, and you have to have every wire that you see there now, and this, all this has got to be dropped down out of the way, and these wires have got to be either disconnected or pulled out of the way so that you can just move that whole assembly, because it's the boiler, the furnace or the firebox, and the manifold, and the fan that's back in here that you can't even see, and the gas valve. All that assembly is all unconnected, stays as one unit, and is pulled out when all this other stuff is out of the way. And to show you the part that was replaced, this is it here. I'll throw it on the ground so you can get an idea. It has a connector right there where you see my foot, and then this white part here is the actual fuse. And when it gets too hot, like wrapped around the boiler, exceeds the mandatory melting point probably, it starts to melt, and that's when it becomes sort of iffy, and then it gets beyond that, it just is totally gone, and of course you have an open line then instead of a semi-partial or whatever. And the issue then is that with that connected and not bypassed with a jumper, you will never have a gas valve function. You'll never have a flame when this thing is broken. And it's a simple continuity test that you connect down here, 2 probes, and set your ohms at 20, and put one red and one black connector on there, and if you can't get into that outlet, either come from behind where the wire is, or use a couple of nails or larger needles to push in there to make contact with the pins, and then use the needles as your contact point, which I did, and there was absolutely no continuity. But like I said, then I checked, come over here to the unit, and I checked this thing right here, which is your high heat boiler water temperature, and it has a pop-out reset fuse on it right here, and it had perfect continuity. So check that. Took this boiler from the top chimney down and blew it out real good. There was some crud in there. I found a big beetle and a couple of bees must have come in from the chimney when it wasn't in use, and then when the firebox came on, they got toasted, because they looked a bit toasted in color. Now I gotta go find me a fuse, which I'm going to put right in here. By the way, this does have a fuse, and it's 250 volt 3 amp quick blow fuse to protect your printed circuit board, PCB. So I get all those things, and I'm going to one final look through and see how it goes before I fire it up.